Welcome to this AWS Marketplace video tutorial by Cybrary.
In this preview, we will cover a brief demonstration of Druva Phoenix. Built on AWS, Druva unifies data protection, disaster recovery, archiving, and analytics for data center workloads both on-premises and in the cloud, and offers the following benefits. Ease of use. Druva is simple by design, no certification or training required. Elastic scale. Built on AWS, Druva's architecture provides customers with infinite, on-demand scale. Built-in security. Druva makes your backup data resilient to ransomware. Lower TCO by up to 50% versus on-premises solutions. Let's take a quick tour to see how this works.
You access the Druva Cloud platform from a web browser, and on the Druva dashboard, you see summary information around the different workloads that you can protect. Whether this is devices, virtual systems, databases, or cloud applications, it's all accessible through a single pane of glass. With Druva in Sync, you're able to back up endpoints and SaaS applications like Office 365, G Suite, Salesforce, Box, and Slack. Because all of the data is centralized in a historical data lake, there are added features beyond backup and restore such as in-text compliance search, defensible deletion, e-discovery and legal hold, and global federated search. From the server side, we have Druva Phoenix. You can back up file systems, databases, NAS devices both on-premises or in the cloud, as well as VMware, VMware Cloud, and Hyper-V workloads. Phoenix also allows you to integrate into your AWS Virtual Private Cloud for an orchestrated disaster recovery. Now, because the data is centralized, Druva can add additional value beyond just backup and restore. Examples include storage insights and ransomware recovery. We're not going to cover these services right now, just wanted to share some additional features and functions of the Druva Cloud platform. Finally, Druva Cloud Ranger enables backup for services and applications running in AWS. Today, we'll focus on Druva Phoenix protection for server-based workloads that run on-premises and in the cloud. On the Phoenix dashboard, you will see summary information on the workloads that you're protecting, whether it's file servers, databases, virtual servers, or NAS devices, regardless of whether they're in your data center or in AWS, say SQL on EC2. Here you can see storage and stats on our global source duplication. The first backup set protected 1.75 terabytes of data. Now with changes over time, we're seeing that grow to 4.52. Now traditionally, if you were to do periodic fulls and archive to the cloud, that data size with a traditional backup approach would compound and compound. There's a lot of redundant data stored within that pool. Now with Druva, we're running our global source-based deduplication, which dramatically reduces storage consumption. So out of this 4.52 terabytes, we've actually only ingested and stored 718 gigabytes. The benefit to you is lower bandwidth consumption and improved backup speed, which allows for more efficient backup of workloads on-premises and in the cloud. You get to choose exactly where your data goes, even though the backend storage is managed by Druva. You choose the region, and then we will triplicate that data to 3 data centers within that region and isolate the metadata in AWS DynamoDB. You can also use different AWS regions to be geographically closer to other business units or to comply with local data sovereignty laws. To configure VMware backups, let's quickly talk through the architecture. All you have to do is deploy a proxy. This is a small Linux-based VM. This is not a repository or virtual appliance. This proxy is used to authenticate to vCenter, authenticate to your Druva Cloud instance, cross-reference what data exists in the cloud, run that deduplication, and then send the unique data directly to Druva. It is worth mentioning that with Druva, you can protect both vSphere on-premises as well as VMware Cloud on AWS and VMware Cloud on Dell EMC. We will choose a workload to protect, select VMware, download this proxy deployer, and copy the token. You use this token to activate the backup proxy. But before we do that, I want to quickly talk about the backup proxy pool. If you have multiple hosts, if you have hundreds of VMs, you can scale out instead of up. Instead of scaling up a proxy, you can have multiple proxies together in a pool. The backup jobs themselves and deduplication will be load balanced, and the data will be deduplicated and sent directly to Druva's cloud based on the schedule and the policy. To quickly highlight a policy, I will create a new policy for VMware by selecting Backup Policy under the Manage tab on our main console. This is where we get to select the frequency of the backups, like when the backups kick off, the max bandwidth of that job, and the frequency. You can have backups run every day up to every hour. It is source-based deduplication and incremental forever backups. On the retention, you choose how many daily, weekly, monthly, and yearlies that you need. If you do have at least one yearly, you can automatically archive older data to Amazon S3 Glacier Deep Archive with a simple selection, saving you costs as this tier costs 30% less, as well as getting that archive data directly into cold storage. As mentioned earlier, Druva can back up both vSphere on-premise and in VMware Cloud. All you do is check this box if you're using VMC and/or put in the FQDN or IP address of the vCenter itself. Input the admin credentials and then determine the location of the data store and network of the host that you want to deploy this proxy. When you launch this deployer, all you need to do is set up your vCenter credentials, data center, data store, and time zone. Then select either a static or DHCP networking. The network just needs internet access. You can whitelist star.druva.com on port 443. Then paste in the token and deploy the proxy. Once you deploy that proxy, what you'll be able to see within VMware is that vCenter loaded all the VMs listed below. To automate backup of VMs, you can use auto configuration. You can set a rule based on a tag, folder, data store, or host. VMs will automatically get added and be assigned to a specific storage region, specific admin group for reporting, a policy for frequency and retention, a proxy pool, and then OS credentials if you're looking to do application-aware backups to isolate SQL data. Once you set that up, the backups will go automatically. If I go under the Jobs tab, you can see from VMware all the backups that have occurred. Because we're using source-based deduplication, only the globally unique data is transferred. The backups themselves go very fast, and the amount of data transferred is very small. This efficiency drives both cost benefits and performance from Druva. If I go to that specific VM, say the SQL VM, and I want to restore it back, there are a couple of options available. You can do a full VM restore or just restore the database. If I choose VM Restore, you have the option of restoring individual VMDK files. You can dive into that VM by mounting that VMDK, browse through the folder directory, isolate folders or files that you need to restore them back to the original or to an alternate VM to a CIFS share as well. You can dive right into the volume, choose the files you need, and then restore that back. From the VM level, you can choose any point in time. Hot would designate local cache, warm would be Amazon S3, and cold is Amazon Glacier Storage. I can restore that VM back to the original or to an alternate location. Next, I choose the VMware configuration, whether it's the hypervisor, the data store, or the network, and rename the VM. We've discussed what recovery options look like, but what happens if your infrastructure goes offline? If you want to configure disaster recovery, all you need to do is deploy a proxy in your own AWS account. Then, from the Druva Cloud platform, you create a disaster recovery plan. The DR plan would highlight the VM boot order and the instance type, automatically copying the latest VM backups into Amazon EBS snapshots within your VPC. This makes your latest backups available for orchestrated failover in the cloud. This is all elastic and scalable. You only pay for the compute out of AWS if and when you need it, instead of pre-provisioning and pre-purchasing all of the hardware and capacity to prepare for the worst-case scenario. This concludes a brief tour of Druva Phoenix, our solution for data center workloads. You can deploy and start using Phoenix in under 15 minutes with no additional infrastructure, and you pay only for the deduplicated storage consumed.
Here we are on the Druva Phoenix product detail page. Druva Phoenix is found on the AWS Marketplace digital catalog. What you are seeing is a sampling of Druva's solutions found in AWS Marketplace. As you can see, the Druva Phoenix product detail page in AWS Marketplace allows you to see an overview of the solution, along with pricing and usage information, support information, and a listing of any reviews on the solution in AWS Marketplace. AWS Marketplace helps customers move to the cloud quickly and cost-effectively by allowing them to find software that runs on AWS from a breadth of categories in AWS Marketplace, test software quickly to validate effectiveness before purchasing, buy through flexible pricing options, and deploy with a variety of delivery methods. Thank you for watching this preview of Druva Phoenix, found on AWS Marketplace. We invite you to explore this solution and many more on AWS Marketplace.